me in an uncharacteristically good mood. Forensics have turned up our first solid lead in the Spectra case. Analysis of evidence recovered at the scene has revealed these two results: an absorption spectrum and an emission spectrum, unique to our suspect. Questions?
Chief?
Detective Buckland, is it?
Yes, sir.
Excellent work on the photoelectric case. Well done.
Thank you for that, sir. I'm just wondering, how are these spectra created?
Good question. Referring to a previous case, we learned that photons can be thought of as packets of energy, and that an electron orbiting an atom can only have discrete or specific energy values. Now, if an electron absorbs a photon of the correct energy value, it will be excited to a higher energy level. However, it's not a permanent move. When the electron moves back to a lower energy level, it must release another photon. The energy of this photon is equal to that of the difference between the energy levels. Now, remember that a photon's energy is inversely proportional to its wavelength, and that is our link to our spectrum. Our emission spectrum is formed when we expose a gaseous element at low pressure to an electric field. The electrons are excited to a higher energy state, and when they return, only photons of a wavelength specific to the difference in energy levels are emitted. So, when we view this through one of our spectroscopes, we only see those photons in the visible spectrum, giving us this unique spectral fingerprint. Now, our absorption spectrum, on the other hand, is formed when we shine white light through a gaseous element. In this scenario, the photons with energy specific to the difference between energy levels are absorbed. But when these electrons return to a lower energy level, the photons they produce are emitted in all directions. So, are you with me? When the spectrum is viewed, we see gaps associated with the wavelengths, giving us our signature black lines. Simple, right? Maybe. So, this is what I need from you today. We have got a number of elements in the lab to interview. I want you hitting that lab, recording every single emission spectrum that you can get your hands on. And one more thing. I want this element identified in the next 30 minutes. So let's move it, people. Let's go.